Factor polynomials. Are you ready?
Yeah!
Yaymath?
Yaymath!
Yeah, it never gets old. Okay, factoring polyo string cheese. Okay. Maybe you're comfortable with foiling. So try to foil this one. I'm sure you're good at it by now. Yeah. Do we have an answer? Yeah.
X squared plus 5x plus 6.
Okay. Equals.
Wait.
X squared. I'll write slowly. Plus 5x.
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 6.
Wait, how'd you get 5x?
3x plus 2x makes 5x.
Oh, you didn't.
Well, you didn't do that
stat.
By now, that's where we are.
Okay.
Okay,
Alright,
good.
whatever you say.
So, just to make it clear, you probably know that this is the F term.
Yeah.
5x is O and I. Outer and inner terms added up. 6 is the L. Okay. Now here's the task for today. The task for today is to go from here to here. So say bye.
Bye.
I'm sure he'd really appreciate that. Or she, or it. Okay. Can you go from here to here is the question. That's what we're going to do today.
You can do anything you set your mind to.
You can do anything you set your mind to. Okay. So, here's how I think of factoring. The first step. If we're going to go from here, reverse, I know that my answer will look like this. So at least I write the parentheses. Then I say, okay, I know the first term is the F term. First times first. So what times what makes x squared? Yes?
X times X.
X times x. So we put it in. I know it's kind of strange because we already know the answer, but it'll help us walk through it one time. Okay, then I look at the 6 and say, how did we get the 6, do you think? How do you, yes?
Why do you skip the 5x?
I'll tell you in a minute.
Okay.
Why do we skip the 5x? I'll tell you in a minute.
Wait.
6, yes?
Well, if you figure out what you need to do to get the 6, then you already know what you need to do for the, like what you'll end up getting.
Yes and no. If you figure out what you need for the 6, possibly you'll get what you need for 5.
You don't really worry about.
Yeah, 6 is more, is as sure as F is L. Because F is what times what equals x squared. And L is what times what equals 6.
And O and I you already have to add.
And O and I are going to add. Yeah, I'm going to write that soon. So what times what equals 6? 2 times 3 or
3 times 2.
3 times 2 or
6 times 1.
6 times 1 or 1 times 6. All right, so keep that in the back of your mind. Think of all the numbers that multiply to 6, factors. Okay, so we try 3 and 2. Try 3 and 2. Yes?
How do we know, do we just know that it's addition because that's addition as well?
In this case, yeah, we know since these two are addition, these two will be addition.
Well, what if it's 2 negatives?
We'll get to that. So for now, leave off the signs is what I'm saying. Leave off the signs in the learning process. Okay? And then we do a quick FOIL to check in our minds. So, let's quickly FOIL this. So what do we got? X squared. Alright, what's the next term? 2x. Notice I'm not putting any signs.
3x.
X squared 2x. 3x.
And 6.
And 6. Okay.
Good job.
So, we look at this. We say, can we somehow, possibly, maybe, hopefully, combine 2x and 3x using addition or subtraction to make 5x?
Yeah.
We can. What do these need to be so that they become 5x?
Addition.
They need to be, yeah, They need to be positive, and we need to add them. Right? Question.
Can you also like do it with the diamond problems?
Diamond problem, that's a method. That is a method, it's fine.
Okay.
That's not how I'm going to teach it, but
Oh, okay.
there are many other methods. Yeah. So for now, 2x and 3x add up to 5 if both are positive. So, if 2x is to be positive, wouldn't you agree that x needs to multiply by positive 2? So here is a plus sign. And if 3x needs to be positive, wouldn't you agree that positive 3 has to multiply with x? And then we confirm in the L of our FOIL, right, the last term, 3 times 2 is 6. These two combine to make 5x and we're done. So this is the answer, right? It was a simple example, but it walks through the process. Okay, we're going to try another one now. Factoring is as crucial to algebra as like a curveball is to baseball, or you know, if someone says they're a baker and it's like, okay, so how's your apple pie? It's like that. You understand the analogy? Maybe.
No.
No? Okay. If I said I was a baker, you'd probably think I have a pretty good apple pie, right?
Yeah.
Okay.
I
If
just
I said
love
I was good at
apple pie.
algebra, I'd probably be pretty good at factoring.
Ah, gotcha.
All right. I'm glad you asked for clarification. Okay, let's do this again. All right. X squared minus, let's do plus x minus 6. All right.
That's a toughie.
It's not a toughie. Give it a try. 30 seconds isn't enough to call it a toughie. Okay. So, first and foremost, we're going to talk about factoring on a global level. The first step in factoring, you should write this down. First step in factoring, find greatest common factor. Greatest common factor. Is there a factor that multiplies into x squared and x and negative 6? No, there is not. So we don't need to factor anything out of this first. I'll show you what I mean in a second. Just keep this, we're starting a list of steps here. Okay. Then we look at this and say, okay, let's start our answer. Okay. Remember what we did last time? Volunteer. Yes?
Well, the first thing that you
Loud.
Okay, the first thing that you would do would be x, and then like in the first.
Here
yeah,
and here you
yeah,
put what?
X,
Why?
because it's x.
No.
It's x.
Right. This is f. So what times what is x squared? We're going to put x times x. Okay, that was good. First step. Then what do we do? Yes?
You put 1 and 6.
Okay, let's try 1 and 6. So put that in red. 1 and 6. Okay, and then we will leave off the signs for now. And we say, all right, let's FOIL this. You know, let's distribute each one and see if it turns into this, right? So what do we get? Can you walk it through?
So x squared,
X squared,
then plus 1 and just plus x.
x squared, and then x goes to 6.
Oh, yeah. Oh, 6x.
6x, then what?
And then 1x.
1x, and then what?
And then 6.
Okay. So let's observe. Let's observe. So 6 at the end works. Can we somehow, using addition or subtraction, combine 6x and 1x to make 1x in the middle term? No, we can't. If we added them, we get 7x. If we subtracted them, we get 5x, or negative 5x, if this was negative and this was positive. So these can't be combined to make 1x. That tells us 1 and 6 are incorrect, so we take them off. 1 and 6 are out. I'm going to take this out. I'm glad we did that. That's good. That's the process. Okay, so what else multiplies to 6?
2 and 3.
2 and 3, 3 and 2. Let's do 3 and 2. Could you walk through the FOIL this time?
Yeah. It'd be x squared
Yeah.
and 2x
Uh-huh.
plus 3x.
So we're not doing signs just yet.
Oh.
Just
okay,
2x and
sorry,
3x.
3x.
Yeah.
And yes.
And 6. Okay, cool. Now look at it closely. I'm telling you it's right. But you tell us, how do we combine this, addition or subtraction, so that the end result is 1x?
Wouldn't it be 3x?
Let her try.
You mean minus?
Minus, which one would be minus? Which one would be plus? Which one would be minus, and which one would be plus? Yes?
Minus 2x
Minus 2x
plus 3x.
plus 3x. Now look at it closely. Would you agree that minus 2x plus 3x adds up to x? Yes. Okay. So, how do we somehow manage to make the 2 here negative? Which of these needs to be negative? Yes? The 2. The 2. How do we somehow manage for the 3 to be positive? What needs to be positive? Yes?
The 3.
The 3. All right, now let's finish it out. FOIL, x times x,
X squared.
x times negative 2,
Negative
Negative
2x.
3 times x,
Positive 3.
positive 3x, 3 times negative 2,
Negative 6.
negative 6x. So we got it.
Perfect.
Okay, questions on this?
Oh, okay.
I love that feeling. Oh, okay. Yeah. Oh, okay. We live for that stuff. Okay, so it's just going to get a little more challenging from here, but the concept still applies. Say goodbye.
Bye. That's going to become a ritual.
Ritual. So also me repeating interesting phrases. That's a nice ritual.
Like what?
Like what? Oh, that was a joke. Okay. All right. First step, greatest common factor. Next step, you can do it like this. Okay? And then we can say, look for F. And then look for L. And then add, subtract for OI. This is borrowing from FOIL. FOIL, all right? First, outer, inner, last. It's the backwards function of factoring. Okay, so are you ready for more? Check this out. Check it out. All right, x squared. Okay. Try to factor this for the next minute, maybe less. See how far you can get. And wait 1 second before you do that. I'm changing it really quick.
Okay.
I'm going to change it just by a little. Okay. So let's factor this. Factor. Factor loosely translates to stuff that you multiply. Pieces of multiplication. So, we're going to turn it into multiplication. Before we saw that this is a multiplication problem. Okay. Let's do this together as you're doing it on your paper. Is there a greatest common factor that we can factor out? Yes, do you see it? X. So I'm taking that out in blue. X. Okay.
What? Wait. Oh, okay.
We'll see. We'll see. Now, what I like to call undistribute. Undistribute. X times what here will result in x cubed? Yes?
X squared.
X squared. Right. So we're undistributing, kind of. See, x times x squared is x cubed. Someone else. X times what will result in negative 4x squared? Yes?
Negative 4x.
Negative 4x. Questions?
No. Yeah.
Please?
Why do you,
Oh. Okay. Yeah.
Why can't you have, like, what happened to the two sets of parentheses?
That's after step one. That's after step one.
What do you mean?
Which is
Step one
step
is-
two, which is two
Yes,
parentheses.
step one, yes. Step one is greatest common factor. So,
Why can't
factor out x. Factor out x. If you have a question, ask it. It's cool.
And then you
basically-
make it into two
Well, no, like,
parentheses.
how do you, like, what is the greatest common factor that you're trying to?
Right. The greatest common factor is what number or variable or both can multiply into x cubed and negative 4x squared and negative 12x.
X.
And that is x. There's an x common in all of them.
Oh.
Common factor.
So then you multiply it.
So yeah, look, distribute this. X times x squared is what? There it is. X cubed. X times negative 4x is what?
Negative that.
So it's the same. Now fill in this.
Okay, so that would be minus 12.
Minus 12.
Yeah.
So you just completed our greatest common factor step. Okay. So we took out the greatest common factor. That's done. Now we're ready for parentheses, parentheses. So this x remains the same. This x stays. And in place of this long polynomial here, we will write.
I have a question.
Question!
Won't we just end up, since we have to distribute, do we have to distribute in the end because of the x?
No, we're going to leave it in factored form. Factored form means turn this thing into pieces that you can multiply. Notice, x times, this is multiplication. This is multiplication.
Okay.
So this has three factors. Three factors. That's the idea. Turn it into pieces you can multiply.
Okay.
That's what factoring is. Okay. I think by now we can do this a little better. What do you think? Yeah?
I got
Just the first two. What is it?
x squared.
Yeah, x squared, but what times what is x
Oh,
squared?
x.
X times x. Okay. And then we go to the 12. Remember, we look for, that was our x. Look for L. All right, someone else? Yes.
6 and 2.
6 and 2. All right, what else could we have tried?
3 and 4.
3 and 4, or
1 and 12.
1 and 12? Okay, 4 and 3, keep that in mind. Keep that in mind. So, 6 and 2. Did you see that 6 and 2 somehow combine to 4? Good. That's the idea. 6 and 2. All right. And what we're going to do here, our FOIL check, it's good for the learning process, but I'm telling you, you do this enough, you can do it quickly in your mind. But let's do it. FOIL to check. X times x is
Squared.
x squared. X times 2.
2x.
Wait. Is that x squared from the two x's in
Yes,
front?
this is out. Disregard this. Yeah, the blue one, disregard it.
So we don't.
It's already factored. It's on the side. This guy.
Okay.
We're checking this. We're checking this now. All right? Pretend this x is not here anymore.
Okay.
Okay? Pretend this x is no longer here. We're looking at this.
So why does it have to be there?
Yeah.
Because it's factored out.
But it's already been factored.
Exactly. Our final answer. Our final answer. Whoa. Whoa! Blooper! Blooper! Is it still? Okay. So that was funny. We're back. Everyone, you survived? Okay, no scars? Got a band-aid on? Stop the bleeding? Okay. X times x, x squared. X times 2, 2x. Then what? 6x. Then what? 12. All right. So we have our 12 here. We have our 12. Now, how do we finagle or manipulate 2x and 6x so that it turns into negative 4x, please?
The 6 behind, there's a negative sign before the 6.
Negative 6,
And then positive 2.
positive 2. Okay.
And then.
So wait, let's look at these.
Okay.
Does 2x minus 6x equal negative 4x? Yeah, so this is our goal.
But we need 4x squared.
4x squared is at the very top, and that will happen after this is distributed. So this x is factored out.
Oh,
Oh, that's why the x-axis is over
Yeah,
here.
the x is factored
So
out.
we distribute it after?
No, we're gonna undistribute. That's what factoring is.
Wait.
I'll tell you in a second. Let's get to the answer. Let's get to the answer. All right?
Hey.
So just tell me what, if this 2x should be positive, what should this 2 be?
Positive.
Positive. There. So x times 2 now is 2x. And if this is negative 6x, 6 is negative. All right? And now we complete x squared, 2x, minus 6x. Negative 6 times 2 is negative 12. Here it is. All right, so this is just, our check is complete. I'm just going to remove it for clarity's sake.
Bye.
Bye, good. Now look at this closely. If we distributed these three, we would end up with this. Okay. So factoring is going from here to here, and distributing is going from here to here. But the point is, these two equations are equivalent. Question is, can you go in this order? Can you start with this and go here?
Yes.
Meaning, yeah, what you would do, if you saw this, if you wanted to check your work, you would FOIL this thing. You would FOIL it, and you would get this thing in the parentheses. I'm sure you can see that. And then if you were to distribute this, you would get here. That's the process. Question, yeah.
Okay, so what would we like circle if we were trying to...
This is the answer. Factoring loosely translates to pieces of multiplication. This is a multiplication problem now. X
So like,
times
wait.
times.
Okay,
Yes.
so we have to continue the problem to find the signs.
Yeah.
So that's why we did that
That's why we
and
did
you
that.
erased it?
Yeah. That was a check.
Okay.
This is the answer.
Okay.
This is factored. Notice it's multiplied by each other. It's 3 factors here. This, this, and this. Okay, I'm going to do one more. One more.
So that's the answer?
That's the answer. This is factored now. This is factored.
So we can box.
Yeah, box. One more.
Bye. So that ritual stopped.
4x squared.
Should we leave that big gap?
I got you. 10, 8. All right. Okay.
Are we ready to start?
Whoa.
I have a question.
Yes.
So for this one, wait, it kind of like has to do like kind of starting to solve the problem. Is that okay?
Yes.
Okay. So because 4 is in common with all of them, would 4 be on the outside?
4 is factored out. Yes. 4 is the greatest common factor.
And that's factored out. So if there's a number that can be multiplied, you know what I mean?
Yeah.
Then it's on the outside.
Yeah. Yeah.
Alright, cool.
So let's write it now. So 4 is the greatest common factor. 4 comes out. All right. Yes.
So then you would do x, and then, wait, do you do, okay, so I know that you want to write the 2, so if there's 2 there.
Would you agree that if you distribute it's that?
Yeah, but wait, do you do like 2 parentheses, like what if
Not
you-
yet.
Not yet?
Yeah, this is
Step 1, greatest common factor.
Okay.
Then 2 parentheses.
Okay, then you do 6, or minus 6,
Minus 6,
x,
x,
then plus 5.
plus 5.
Yeah.
Okay. Now we've factored out the greatest common factor. And 4 is still here. Here we go. Try this out. Put your F term in, the first.
X and
Put
O.
the first, yeah, I'm gonna give a little time for people to try. First here, so that's X and X, that's right. Okay, and then we look for L, which is the 5, yeah?
6 and 1.
5.
So 6 and 1 subtracted is 5.
I know, but think of it in terms of multiplying.
3 and 2.
Now multiplying to 5, yes.
5 and 1.
Yeah, multiplying to 5.
Multiplying is 5. Oh, right.
Yeah.
The last problems we've done, look at your paper. It multiplies to this last term. It multiplies to the first term, it multiplies to the last term. Multiply. Multiply L. And then add or subtract to 6x, negative 6x. So what multiplies to 5? We heard it, 5 and 1.
5 and 1.
5 and 1. All right. FOIL to check it. X squared. 1x, right? Stop.
Why'd you write the 1?
Yeah, x is fine. X is fine. I know, I'm being very formalized. X, and then 5x, and then 5. Okay. So we did our F, we did our L. Add or subtract to get O and I. How do we combine these to make negative 6x? What do they need to be? Yeah.
Negative x and negative 5x.
Both need to be negative, correct. If both are negative, this needs to be negative to make negative x. This needs to be negative to make negative 5x. And then notice, negative 5 times negative 1 is plus 5. Amazing, man. All right, and this is done. So, this is the answer. Questions? Questions? Yes.
Okay, so are we trying to find the thing in the blue parentheses or like the?
Red box.
No, I know.
Oh.
But like I don't get how that like relates back to like the original problem with the black.
Distribute this, and you will get this. Guaranteed. You know how to distribute, right? Yeah, you know how to distribute. Let's say I asked you to FOIL this. If I asked you to FOIL this, you get this thing.
And then.
And then if I asked you to distribute here, you get this thing. So I'm not asking you to go this way now. I'm asking you to start here and go this way. That's what factoring is. All right? Thank you. That was a fun little blooper. Thank you. Bye. Have a good life.
Blooper.